Alright, so number 40. We have the following problem. 40 says find the sum from I equals 1 to 7, 4.5 times 2 to the I. It's worth pausing just for a second to write what this means, like what is this actually asking us to calculate. So what this is saying is find the sum of terms 1 through 7 of the sequence generated by 4.5 times 2 to the I power. That's what they're asking us to do. Find the sum terms 1 through 7 of this sequence. Now, of course, there is always, whenever you're finding a sum, arithmetic or geometric, or in fact, if the sequence might be neither arithmetic nor geometric, you can simply plug in 1, find the value of the term, plug in 2, find the value of the term, plug in 3, find the value, 4, 5, 6, 7, add those all up. Now, that might not seem very tedious when there's only 7 terms. Imagine if there were 100 terms, it's extremely tedious, which is why we prefer to use the formulas. Now, in order to use the formulas, we have to determine if this is an arithmetic or a geometric sequence. And of course, the way we do that is we simply begin to identify few terms from the sequence. So if I equals 1, we have 4.5 times 2 to the first power, which equals 9. If I is 2, we have 4.5 times 2 squared, which equals 4.5 times 4, 18. If I equals 3, we have 4.5 times 2 cubed, which is 8 times 4.5, 36. What you're noticing, of course, here is that every time to go from one term to the next, we're simply multiplying by 2. So let's say r equals 2. And of course, remember, r is just the common ratio. Anytime we talk about common ratio, we're talking about a geometric. And anytime we talk about geometric, we know we have the formula S sub n, and we know we want to use this formula because it's asking for a sum. S sub n equals a1 times 1 minus r to the n, all divided by 1 minus r. And now we simply need to plug in what we know. And I think it bears repeating that I think this could be a non-calculator problem, so I just want to make sure everybody knows how to do it without the calculator. Not that you shouldn't use it on this, but just so that you know how to attack it if it's a non-calculator portion of the exam. So let's plug in what we know. Well, we know we're trying to find S7 because we want the first 7 terms. A1 is 9. 1 minus r is 2 to the n, so 2 to the 7th, over 1 minus 2. Simplifying it here. Downstairs, 1 minus 2 is negative 1. Upstairs, we have 9 times 1 minus 2 to the 7th, 2, 4, 8, 16, 32, 64, 128. So, of course, now we have 9 times negative 127 divided by negative 1. 9 times negative 127 is negative 1143 divided by negative 1 equals 1143 The negatives go away, of course, and there's your final answer. I'd like to stop here and take some questions on number 40. Okay. Now, as many of you know, in math there's often multiple ways to solve a problem. And sometimes it's beneficial to use one strategy, sometimes beneficial to use a different strategy. So I would like to resolve this problem using a different strategy. A, so you all know how to do it, and B, so that if there is a problem where the other strategy could be more effective, you'll be able to do it that way. And in fact, this other strategy, I think, is conceptually slightly more challenging, but definitely easier with the calculations. So let's see what that looks like. So I'm going to solve it, and I will end up with the exact same 1143 answer. So let's see how to do that. So, sum, and we're going I equals 1 to 7 of 4.5 times 2 to the I. Okay. Now, if you notice, on the previous problem, step 1 was identifying whether it was arithmetic or geometric. I mean, I wrote what it means in words. That's not really a step. That was just kind of what was going through my head. And then I found the terms, identified the pattern. If you notice, when I sort of calculated each term, I plugged in 1, 2 to the first power was 2, then I multiplied by 4.5. Second term, plugged in 2, 2 squared 4, then multiplied by 4.5. Third term, plugged in 3, 2 cubed 8, then multiplied by 4.5. What I'm beginning to notice is every term was calculated by 2 to the power and then multiplied by 4.5. Every term was just somehow multiplied by 4.5. Of course, that's because this appears here. Rather than multiplying every term by 4.5, I could simply multiply the sum at the very end by 4.5. So just instead of multiplying each term by 4.5, in other words, factor, in some senses, the 4.5 out, and just solve this problem with the 4.5 on the outside. This is very similar to what I did when I was saying that the ball was thrown up and we wanted to find the distance traveled, and we multiplied by 2 because the ball went up and then down. If you solve this problem, A, the calculations are much easier, B, you'll end up at the same answer. So let's go ahead and model the calculations for this problem. So we need to solve this black box first, then at the end multiply by 4.5. Solving the black box, of course, if I equals 1, we have 2 to the first power, which is 2. I equals 2, we have 2 squared, which is 4. And if I equals 3, we have 2 cubed, which is 8. So R, of course, is 2. So now we'll just simply apply our formula. S7 equals A1 times 1 minus R to the n all over 1 minus R. So this is 2 times 1 minus 2 to the 7th power, we said was 128, all divided by negative 1. So S7 equals 2 times negative 127 over negative 1. 2 times negative 127 is negative 254 divided by negative 1. So S7 equals 254. And then just take 254 times 4.5. If you do that on your calculator, you will get 1143. So you do 254 times 4.5, and you get 1143, which I should point out is the same thing we got here. One way is not any better than the other, just two different ways of attacking the same problem. Let me pause here and see if there are any questions on that before I go forward. Right here? 2 times negative 127?
If I is 1.
If I equals 3, then 2 cubed. This just means then.
You know what?
4 times 2 is 8. R equals 0. Okay, let me go ahead and go on number 38 now. Let me go ahead and go on number 38. Yeah, because I wanted to teach the skills first from that problem. Should have put that one first, I just didn't think so much when I made it. Okay. Alright. Now, there are many people in this class, in the other classes, in last year's class, in pre-cal classes, bless you, around the country, who will attack this problem exactly like they attack number 40. There's parts of that which is good, and parts of that are not so good. The major difference between this problem and number 40 is that this has a k equals 0, whereas 40 began with k equals 1. If you think about the formulas we use for arithmetic, for example, sum, the formula is S sub n equals 1/2 n a1 plus an. Of course, for geometric sums, the formula is S sub n equals a1 times 1 minus r to the n all over 1 minus r. When you look at both of these formulas, please notice that they look at a1, not a0. They both require some knowledge about a1, not starting at k equals 0. My point is simple. These formulae are not applicable for a problem that starts with k equals 0. We therefore need to rewrite this green to make these formulas applicable.
So in this case, 1 and change the 5 to 6, so we do the same thing.
You're halfway there. You're halfway there. So Shanli is already getting to the beginning pieces of this, which is get this as k equals 1. That's where we want to start. And please note that this green had 6 terms initially. Term 0, term 1, term 2, term 3, term 4, term 5. Which means the yellow should also have 6 terms. Term 1, term 2, term 3, term 4, term 5, term 6. So you need to change the 5 to a 6. You change the downstairs lower bound, because remember lower bound to a 1. We need to change the upper bound to a 6 to keep the same number of terms. Again, we don't want to have a different answer than this. We just want to rewrite this so this formulae are applicable. Now the question is, what needs to go in here? And to discover that, let me prove it analytically, and then I'll give you the rule. The analytical proof is as follows. In the green, if k equals 0, we have 1/2 times negative 3 to the 0 minus 1. So we have 1/2 times negative 3 to the negative 1. So we have 1/2 times 1